Alright, welcome to this very special episode of Physics Survivor, where we're pitting the brightest minds in science against the trials and rigors of nature.
Nature, I was published in Nature last month. Can I go home now?
Not that type of nature. Now, before we begin our competition, let's meet our contestants. In the first team, we have the theorists. In the first team, we have the theorists with years of experience in pushing the limits of caffeine consumption. In the second team, we have the experimentalists, well versed in the arts of spending too much money. Alright, now each of our contestants has been allowed to bring supplies that they think will be useful for their quest for survival.
All I brought was my copy of Jackson.
As our first challenge, we'll see if our competitors can make fire before night falls and the temperature plummets to a frigid 61 degrees Fahrenheit.
I'm from Chicago. I don't really understand Fahrenheit. Could you convert that to millikelvin?
Sorry, I cannot. All right, good luck.
Clearly, we're not getting anywhere without fully characterizing the phase transition of cellulose.
What's the dimensionality of the phase space? My equations only work if there's at least 8 dimensions.
Now stop it, guys. I think we really need to calculate the packing fraction of the sand. See, when I shake it up, everything just changes. I mean, it's crazy.
We need to add more dimensions. That always fixes things in a pinch.
Wait a minute. We can use these glasses as a lens. What's the dielectric constant of glass?
It should be 1.
Don't we need to think about the... Don't we need to think about the power spectrum from the sun?
Let's say that's 1.
And the emission point of wood?
It's all 1!
Well, obviously, but what about the units?
There are no units!
Sorry,
Units only get in the way of the beauty of the equation.
Well, we're not going to get anywhere without rewriting the Sackur-Tetrad equation.
In 10 or maybe 10.5 dimensions?
In n dimensions, we can construct the n-dimensional partition function of the grand canonical ensemble, and that will tell us everything we need to know about the fire, survival, and the universe.
I don't know. I'm sure we could make this fire in theory.
This is turning out to be a real grand canonical disaster.
Before we start, has anybody passed the online fire safety training course?
I think I took it 5 years ago, but I don't think I passed.
Oh, EHS will not be happy about that.
How about I take the course tonight and then we can make the fire tomorrow?
But it can take up to a week to get certified.
I don't really care, NSF pays me either way.
We don't want to lose funding, so let's just freeze tonight.
Due to our contestants' failure to make fire, we have given them everything they need for our second survival task, catching a fish in the wild to avoid starvation. Good luck.
Oh look, there's a group of fish over there. Alright, all we need to do is fire this projectile at it and catch one.
I think we should use the equations of motion that we learned in kinematics. Let me just start to write these down in the sand.
Right, make sure to account for air resistance.
Right, and also Snell's law because they're not where they appear to be.
Well, don't worry, I'm using index notation and all the good stuff, setting all the speeds of sound equal to 1. It's perfect. It'll work out.
Assume that the projectile is a 5-dimensional manifold.
And topological isomorphism should preserve data variance.
And definitely, we gotta set double R to all the real projectiles. That'll do it.
Right, and the Coriolis force bijectively maps to the reflective Lagrangian.
And we don't know how many fish there are, so we need a Fox space to account for all possibilities. You know, like 1 fish, 2 fish, red fish, blue fish.
I think we're done here. I think we know what to do.
All right, let's fire away.
So the fish is right there, and we just pull this back and fire! Wait, that didn't hit the right thing.
Oh, my bad. That was on you guys. I forgot on my side.
Hey guys, look. Luckily that fish was already trapped by a rock for us.
Oh, thank God, easy dinner tonight.
Oh no, we're keeping this one. Why? For sleep experiments.
But if we don't eat it, we're gonna starve.
I want to know how many eggs it's going to lay if I keep it awake. Forever.
have failed another key survival task. However, they have one last chance to redeem themselves in our third and final challenge, making a raft to escape the island. Don't disappoint me.
All right, well, if we're building a raft, we're going to have to solve the wave equation for this beach.
Wait, what's the wave function of the ocean?
We need to calculate all the Reynolds numbers for all the things that we're using first. I mean, that's what we do.
Oh shit.
Can he swim?
In theory.
Help me, please!
I guess not.
Our contestants have failed on all three survival tasks and nearly drowned one of their own members. Do you guys have anything to say for yourselves?
We didn't have enough funding.
No, we didn't have enough coffee. That was really good.
Ugh. Clearly, both theorists and experimentalists are unsuited to face the trials of real life. Join us next time to see how physicists survive in a grueling office environment.